For all right triangles, remember we have the Pythagorean theorem where we have our two legs a and b, hypotenuse c, and for any right triangle a squared plus b squared equals c squared. And then we also have SOHCAHTOA that we can use for all right triangles where we have our opposite and adjacent side determined by our angle. In this case theta is here, so we have our opposite, here's the adjacent, those two legs in our right triangle, and then of course the hypotenuse opposite the right angle. So using these, if we're asked to solve the triangle, what that means is we're going to find whatever's missing. So in this case we're given one leg is 2, we're given the hypotenuse is 5, so we can use Pythagorean theorem. So we know 2 squared plus b squared equals 5 squared, and we can solve for side BC. So if we subtract 4 from 25, we have b squared is equal to 21, so b is equal to square root of 21. Now as far as solving for angles, let's say if we're looking at angle B, then I know here's my opposite, here's the hypotenuse, so I could set this up as the sine of angle B is equal to 2 over 5. And anytime we're solving for an angle, we'll use the inverse. So we're going to say that angle B is equal to the inverse sine of 2/5. This is where we then use our calculator. We're going to say the inverse sine of 2/5. We can find that angle B is approximately 23.6 degrees. Now we already know this angle is 90 degrees, so if we have B is 23.6 degrees, triangles add up to 180. A and B would be complementary angles, so if we take 90 minus our answer, we can find that angle A would need to be approximately 66.4 degrees. So now we have solved the triangle and found all the missing parts. The other thing we're going to be doing in section 4.1 is we're going to have to set up our own triangles. Something that we're going to need to use to help us with this is if we're talking about bearing or direction. Now when we're measuring bearing, what we're talking about is, imagine if we draw a map, north is always up, south then would be down, west and east, so it spells we. Remember, never eat soggy waffles, however it is that you remember that. And these are going to make a right angle. They're intersecting. It's like an axis here. When we're measuring the bearing, we'll either measure from north or from south. So for example, if I'm measuring from north and I have a vector off this direction, then we could say that maybe this angle is 40 degrees, in which case we would say that our bearing is north 40 degrees to the east. Or if we have something coming off this direction, now our angle here is maybe 70 degrees, so then we would say from north 70 degrees to the west. We could also measure something over here in quadrant 3. Maybe this is 30 degrees. And so now we're going to say that this bearing is from the south, and it is 30 degrees to the west. Or if we're measuring this direction, here again this angle we're saying is maybe 50 degrees. So from the south, 50 degrees to the east. So as you set up that, if you're given the bearing of something, we would go from either from the north or from the south, and it gives us our angle that we're measuring and what direction we measure it to.